I'm Sister Margaret Mary, Assistant Professor, Department of Computer Science, Fatima College, Madurai. We are going to see in this session what is functional independence, cohesion, classification of cohesiveness, coupling, classification of coupling. So a module is highly cohesive and also has low coupling with other module is said to be functionally independent of the other module. It is a key to any good design. It offers following advantages: this error isolation, scope of reuse, and understandability. So when an error exists in a module, functional independence reduces the chances of error propagating to the other module. The reason behind this is that if a module is functionally independent, its interaction with the other module is low. If any failure is detected, error isolation makes it very easy to locate the error. The module can be reused for the development of the other applications. A functionally independent module performs some well-defined and precise tasks, and the interfaces of the module with the other modules are very few and simple. A functionally independent module can be easily taken out and reused in a different program. So the understandability. When a modules are functionally independent, complexity of the design is greatly reduced. So it is very easy to understand. Cohesion. Cohesion is a measure of functional strength of a module. Function of the module cooperate with each other for performing a single objective, then the module has good cohesion. Classification of cohesiveness. Cohesiveness of the module is the degree to which the different functions of the module cooperate toward a single objective. The different modules of the design can possess different degree of freedom. So the classification of cohesiveness, that is coincidential cohesion, logical cohesion, temporal cohesion, procedural cohesion, communicational cohesion, sequential cohesion, and functional cohesion. So the coincidential cohesion has to be low and the functional cohesion has to be high. So if a module performs a set of tasks that relate to each other very loosely is said to be coincidental cohesion. A module contains random collection of functions. For example, the function name library that has the random collection of functions that issue book, create number, compute vendor credit, request librarian, leave, etc. A module is said to be logically cohesive if all elements of the module perform similar operations such as handling data input, data output, and so on. For example, a module that contains a set of print functions to generate various types of output reports such as grade sheets, salary slips, annual reports, and so on. Temporal cohesion. When a module contains functions that are related by the fact that those functions are executed in the same time span, then it is said to be temporal cohesion. When a computer is booted, several functions need to be performed. Initialization of memory and devices, loading the operating systems and setup, and so on. Procedural cohesion. If a set of functions of the module are executed one after the other, is said to be procedural cohesion. These functions may work toward entirely different purpose and operate on different data. So the order processing in a trading house, the functions are login, place order, check order, print bill, place order on vendor, update inventory, lockout. So these functions may process a different data and they are defined for the different purpose. Communicational cohesion. If the functions of the module refer to or update the same data structure, is said to be communicational cohesive. If a module named student and the functions of the module are admit students, enter marks, print grade sheet, etc. So these functions access and manipulate data stored in an array named student records defined within the module. So module is said to possess sequential cohesion if the different functions of the module execute in a sequence and the output from one function is input to the next in sequence. So the functions create order, check item availability, place order on vendor or place in a module. So the function create order creates an order that is processed by check item availability is input to place order on vendor. A module is said to possess functional cohesion if different functions of the module cooperate to complete a single task. A module contains all the functions required to manage employees' payroll. A function of the module like compute overtime, work hours, deductions. So those work together to generate pay slips of employee. So now we are going to see coupling. So the coupling is the degree of coupling between two modules depends on their interface complexity. So the classification of couplings are content coupling, common coupling, control coupling, stamp coupling and data coupling. So the strength of the content coupling has to be high and the data coupling has to be low. So the content coupling exists between two modules if they share code. That is, a jump from one module into the code of the other module can occur. So the modern high-level programming language such as C do not support such jumps across modules. Common coupling. Two modules are common coupled if they share global data item. Control coupling. If the data from one module is used to direct the order of the instruction execution in another. So the flag set in one module and tested in another module. Stamp coupling. If two modules communicate using composite data items such as a record in Pascal or a structure in C. Data coupling. If two modules communicate using elementary data item that is passed as a parameter between the two. So integer, float and characters, etc. This data item should be problem related and not used for control purpose. Thank you.